Today we're solving an exponential equation using logs. We are going to be going to the decimal, so that means we are going to be using the change of base formula to help finish solving these. So if we have 7 to the 2x plus 3 equals 52, we want to find out what is x. The only way to find out the value of x is to get the x by itself. So that means get the x isolated. To do that, we're going to change forms into logarithms. So we're first going to have to change it into a logarithm today, and then we're going to, when we're solving it, apply change of base. So if we want to change it into a logarithm, how would I change this into a log? We go fishing. So where you start is always at your base. So log base 7, then where we follow through, that's going through the 52, so that's the next number, at 52, and where we end up at is always on this side by itself, 2x plus 3. Now, this whole thing is a single number. You cannot bring anything into it or take anything out of it unless you manipulate the 52 to bring it like a 2 to a power or something like that. But in this case, on 52, we're not going to be manipulating. We're just going to leave it as 52. So I will oftentimes put parentheses around that number so I know that I can't change that number without just changing the 52 to another product of 52. They create 52. So when I bring that 3 over, it cannot go inside that red circle. It's just going to hang out at the end. So log base 7 of 52 minus 3 is equal to 2x. If I was to solve for x, what would my next step be?
Divide by 2.
That whole thing is going to get divided by 2. Now we are going to change base. That means I'm going to use the change of base formula that we learned last week for that log base 7 of 52. And so we have log base 10 of 52 divided by log base 10 of 7. Remember, there's log of the big, the larger in size number, divided by log of the small, your smaller in size number, or log of the answer portion divided by log of the base. Minus 3, all divided by 2. What I wrote in red, I would recommend doing in your calculator first. And then using the ANS option to bring that answer down to the next step. We are going to round our answer to the nearest 10,000th, so 4 decimal places out. So that number is approximately what? What number did we find out that decimal is approximately?
2.
Not approximately 2. 0. What? 48. 2 more numbers. We need to go 4 decimal places.
4, 7.
So let's check to see, is this going to give us a positive number in our exponent? Why is that important to check? If I raise this to a negative exponent, what will happen to the other side is going to be like 1 over.
Wait, is the 0.4847 a negative or a positive?
I thought it was a negative.
It is a negative.
Did I not write it? No. Okay. And so this is approximately 0.5, negative 0.5. So 2 times negative half is going to be what number? Negative 1. Plus 3. So I'm not going in there and finding out this number is exact, but I'm just doing an approximation to see, is it seem reasonable for that to be the exponent? Yes. So we're going to go through two more of these. So what do you think I'm going to do first on this problem? Go fishing. And so we have log base what?
17.
Of
102.
equals
-2x plus 3.
what am I going to do next?
Minus the 3.
Can it change the 102?
No.
So this will be log base 17 of 102 minus 3 equals a negative 2x. What would I do next?
Divided by -2.
And then what do I need to do? Do my change of base. Log of the bigger in size number
102.
divided by log of the smaller in size number or the base minus 3 all divided by -2 is equal to x. And that is approximately what number? Point 6838 is approximately what that comes out to. And so that's approximately 0.7. So -2 times 7/10 is going to be a negative 1.4. Plus 3, is that positive or negative?
What do you minus 3?
I'm plugging it back into the
yes,
exponent.
okay.
So plus 3 is positive or negative? Positive. And so that means that does seem reasonable. Last one. What are we going to do first? Go fishing. So log base what? Of
0.
equals.
X plus 5.
Can we have log base anything of 0?
No,
No.
Why?
because it would equal 0.
Because the only number that can be raised to a power to equal 0 is 0. Undefined or no solution. What other numbers can this not be? No, not 1. 1 will be a 0. Negative.